Okay. All right, so today's going to change a little bit because we're going to look at period changes. Period changes occur when we have a number in with our angle. Remember this variable here, that's theta. It could be an x, it could be a beta, anything, right? This location represents the variable for our angle. If it were just a regular problem, it would just be a variable. When it's glued to a trig function, it means it's an angle, like pi over 6 or pi over 4, whatever you get. This is the b. Remember, new period equals old period over b. So what is the old period for sine or cosine? What's the parent period for sine or cosine? 2 pi. What's the old period for tangent? Pi. So tangent has a shorter period. So if you want the new one, you have to take the original, which is either going to be 2 pi or pi, and divide it by b. That number right there next to your angle. But you don't do it till the very end. So this isn't going to be too bad, right? When we have to divide. So what we want to do is yesterday's work right here, and we're going to compare it to something we're learning today so we can see the difference, okay? So tangent theta equals the square root of 3. Well, we're going to follow our system and choose the location of where it lives first. Where is tangent positive? Because it's slope, it's positive this way, negative that way. I really want you to tie tangent to slope. Okay? And what family is tangent the square root of 3? The family pi over 3, right? That's a 60 degree. Once I know what family it's in, I need to identify the names in this location. It's going to get tricky. This is pi, this one is pi over 3, and this one is what? 4 pi over 3. Okay? Now, we got to think about this. There's something's going to change. What are your directions? So if any of your answers are bigger than one period, we cannot use them. Now, what's the period for plain old tangent? Pi. Tangent is pi. Now, are any of these answers bigger than pi? Okay, this is too big. Because it says solve over one period. So we're not going to write that down. And the only answer we're going to take is that one. Yesterday, our instructions, let's go back and look at that so you'll know that you're like, what happened? If you look at, I want you to see what yesterday said. I don't want to just tell you, I want to show you. So if you look at yesterday, it said solve and find solutions between 0 and 2 pi. So you have to go all the way around the circle. So this is kind of like saying you can't go as far. We're shortening the leash, if you will. You can't go as far as you used to be able to go. Is that okay? All right, let's compare it to this guy and see if there's a difference. I'm not even going to worry about the period first. Before I do anything, I want to try to do what I already know how to do. So again, tangent is positive here and here, and that's the pi over 3 family, right? That's a pi over 3 family because it's the square root of 3. That I have to bring with me. But remember over here where we were saying theta equals this, right? Now we're going to, instead of saying theta equals pi over 3, now we're saying what? 2 theta equals pi over 3. 2 theta equals 4 pi over 3. Now, I don't know if these answers are going to be acceptable yet. I'm just going to solve them, okay? Now, I'm going to multiply by a half. Do you see how I have to multiply by a half now? Because there's a 2 there, I have to get the angle by itself. I cannot do anything with this 2 till I get rid of the word tangent. The word tangent is gone when I convert this to an angle. Think about that now. Whenever I turn this value into its angle, tangent is gone because I've figured out what tangent of that angle is. Invert anyway. Now I multiply by a half to get rid of the 2. So that is pi over 6. And that is what? 2 pi over 3? So there's different ways to, there's different ways to approach this. My way is I just solve the problem like I would, don't want to think about anything else. Then I go back and I decide what the period is and see if I need to exclude anyone because they're too big, right? That seems easier to me. Do what I did yesterday, except I have to clear off the 2. Now I'll go account for the period, and if somebody's too big, I won't worry about him. So the new period, what's the new period here? It's the old over b, so that's pi, which is the period for tangent, over 2. And if you want really good notes, see how I'm connecting those so later tonight I don't say, why did she divide by 2? You ever get home and do that? Like, why did I do that? So now I can see that that 2 came from there. You know, I love the highlighters. So, oh, what did I do? What did I do? That's a 6. No, that's a 3. Never mind. Okay. My new period is pi over 2. Where is pi over 2? That's pi over 2, right? So essentially, what am I only accepting? Answers in the first quadrant, right? So am I going to accept those answers? This is too big, isn't it? Don't just, write down too big. Write y. So I only have one answer now. Is that good? Does that make sense? Make sure you're writing things in your notes, because when you start your homework, a lot of times I see kids put their notes away. You should have those on your desk, right? Okay, are you ready? All right. Let's solve this thing. Is there anything to simplify, or is it already simplified? It's already simplified, right? There's nothing to move over. There's nothing in front of sign. And I can't take that 2 out of there till I get rid of the word sign. So where does sign equal -1? 3 pi over 2, right? So if you don't instantly know that, you don't know your unit. You go back and review that unit circle. But instead of saying x equals 3 pi over 2, what do I have to say? 2x, and now I cannot leave that 2 there. So what do I do to get rid of a 2? Yeah. So now I have x equals 3 pi over 4. If this were yesterday, I'd be done. But it's not yesterday, it's today. So I have to now account for the period to see if I'm going to accept any answers that I have. The new period is what? Old, right? Keep writing old over b. Every time you write that, it gets stuck in your brain a little bit better. So what's the original period for sine? 2 pi. And what's b? 2. Again, get a highlighter or something. Right? There's a lot of 2's here. We don't want to get mixed up where that 2 came from. So that is pi. Now pi is right here, correct? So since the period is pi, you're only going to accept answers to there. If anything is bigger than that, you wouldn't take it. Is 3 pi over 4 okay? Yes, that is acceptable. Right? Now things are going to get a little weird. Are you ready? Are you ready for weird? Okay. I better get a different color. Okay. This looks exactly like this to me. Does it look the same to you? It does. It looks exactly the same. I think my teacher's crazy. What's the difference? Most of the time when you do problems, these will be the instructions. More often, these will be the instructions. Very rarely do you see this. But we did those to get you to think about what a period is. This is usually what it looks like. We solve one circle. Well, let's see how this differs. Is the beginning part going to differ? No. So I'm going to say 2x equals 3 pi over 2. I'm going to get rid of the 1/2, get rid of the 1/2, or the 2 by 1/2. Now, what is the period here? We already figured it out here. What's the period? Pi. Okay. So now, kind of. So let's look at this, right? I got an answer here, which is 3 pi over 4, right? But my directions this time say to go from 0 to 2 pi. So I don't know if I can fit some more in here, because I'm going to go all the way to here this time and look for answers. So what I have to do is take the answer I got and see if I can fit one more sine wave in. How would I know if I could fit one more sine wave in? Yeah, how do I add another wave? How big is a wave? It used to be 2 pi, but how big is one cycle now? Pi, so I need to add pi. So I'm going to say 3 pi over 4 plus 4 pi over 4. So what is that answer? 7 pi over 4. Does that fit within 2 pi? So I have to take that answer too. So this time I have 2 answers. Now just take a minute and think about that. Remember what this little 2 does. It says by the time I go around the circle once, I have 2 waves instead of 1. I'm supposed to get 1, but now I have 2. So when we find our answer, the period is shorter. I have to look and see if I can fit another one in. And this is, you're going to see these. That's usually the way it's written a lot more often than this way. Okay? Is that okay? We're going to do it again. We're going to run another problem. Just notice I put versus this one versus this one. And what I'm wanting you to see here is the directions. I knew where my blue pen went. There it is. Right? So it's almost the same problem. All right, so let's, now this one's a little more interesting. What's going to happen with a square? How are you going to get cosine alone? Yeah, you're going to have to square root both sides. And when you square root both sides, what happens? To any equation anywhere, if you say x squared equals and you square root both sides, you get a plus or minus. Remember, let's put a special note in a special color. If you forget plus and minus, do you get any credit? No, there's none. With trig equations, if there's 7 answers and you don't get all 7, you get nothing, right? Okay. Are you ready? I think I can do it. All right. Is it, we got to do what first? Square root both sides. So now I have cosine. The square root just takes the x off, the 2 off, sorry. What is the square root of 1/4? Well, the square root of 1 is, what's the square root of 1? What's the square root of 4? There we go. Now, where does this creature live? It's plus or minus. So the plus lives here, the minus lives here. How many answers am I going to get? I'm going to get 4. Now, I'm going to deal with the period in a little while. I don't know if 4 is going to be too many or not enough, right? But I think I'm better off just to do what I do, then go make period adjustments. It's too much to think about at once. Okay, here we go. What family is this? Which one? Come on now, where's cosine of half? Pi over 3. Sine is a half at pi over 6. This is cosine. So instead of saying x equals pi over 3, right, I'm going to have x minus 2 equals. Now, what are all my pi over 3s? I have pi over 3 here, 2 pi over 3 here, 4 pi over 3 here, and what? 5 pi over 3 here. So I get 4 answers. But it's not x equals, it's what? X over 2. Now, I know you could probably do this faster, but in your notes, write each one out. So when you go to look back at this, you need room to do your math. Right? Are we good? What are we going to do now? What are we going to multiply both sides by to get rid of a 2 on the bottom? Yeah, so we got to multiply by 2 and 2. Now, if I were doing this just for homework, I probably wouldn't be writing all this out because I'd see the pattern. But these notes are my message to myself later today, and I might need to look at that. So what answers do we get? 2 pi over 3, right? 4 pi over 3. Well, I'm going to move that. I can't fit them all down there. I write too big. 4 pi over 3. What's next? 8 pi over 3. And what's next? 10 pi over 3. Now I need to ask myself, are these answers acceptable? What, like 10 pi over 3, how big is that? That's like 3 1/3, right? It's pretty big. But what's the new period? Well, it's the old over the b. What is 2 pi over 1/2? 4 pi. So if any of these answers are smaller than 4, they're acceptable. Are all of these answers smaller than 4? Yes, they are. So I can accept all of them. Now, this is the same problem, so we don't have to redo all of this, right? We already did the work. So let's use our same answers and see which ones are acceptable on this one. The process will be the same, yes? Right? All of this work would remain the same. What changes for this guy? The period is still the same, right? It's still 4 pi, but that's irrelevant right now because what does this say? I can't use any answers bigger than 2 pi. That's what this means. If I get to 2 pi, I'm done. So let's make a special note of that. Include values up to, but not including 2 pi. Notice it's a parenthesis right there. You may include 0, but you don't write the 2 pi down. 2 pi is the same spot as 0, isn't it? It just means you went all the way around. So include values up to, but not including 2 pi. Is 2/3 smaller than 2 pi? Okay, this one is acceptable. Is 4/3 smaller than 2 pi? Yes, that's acceptable. Is 8/3 smaller than 2 pi? No, 3 goes into 8 more than 2 times. Is 10/3 smaller than 2 pi? No. So take a second to look at that. Digest what we just went through. Take a minute, write some notes on your paper that will help you remember this tonight. You can see where things are building, and we've got to be okay with this, right? I think they're kind of fun. Okay, but I'm strange, right? So what's changed between regular equations and these equations? Basically, right, you might have to adjust for a small number right there. And then you have to basically evaluate whether or not you're going to accept all of your answers. That's the big difference. Which answers are you going to take? It's kind of like if I get to pick 3 of you and go to Starbucks, which 3 am I going to take, right? Somebody's going to get left behind with these period changes. Not too bad though, right? Did everyone make enough notes to where you've written down things to yourself for tonight? Right? Okay. Then we're going to try a couple more and we're good to go, right? Not too many. Next class, we go back to our identities. All right. What should we do first? Well, remember yesterday we made a cheat sheet. We added to it, right? And we said what we're going to do is get it equal to 0, combine like terms, then we factor. Right? We simplify just like we did in algebra. It's just there's words in it. And then we choose our quadrant, choose our family, choose the correct angle. That's it. You wrote it down. You have a list. Okay? So how do we get, this is the guy, right? This is the guy we want to get all by himself. So what do? We move 2 over and then divide by the square root of 3. Okay. Now, should I immediately panic that I got a radical on the bottom and a secant? No, because I don't do secant, do I? What do I do if I have secant? I flip it over. I flip over both sides. And when you flip secant, you get cosine. And if I flip this over, it turns into a buddy of mine. I like him. He's on my list, right? Where do we go from here? We decide the family. What family is this? It's pi over 6. Now, it's negative, so where's cosine negative? The left side, right? Because cosine means x, and x is negative on the left. Okay, so what are the names of these? This is 5 out of 6. This is 7 out of 6, right? Okay, so, but now I have this 3 there, so instead of just saying that, I have to say 3x equals 5 pi over 6, and 3x equals 7 pi over 6. Can you read that? Okay. And how do I get rid of a 3? Yes, I do. You can say divide by 3, but I think it's easier for you to see the math when you multiply by a third. So what does x equal? 5 pi over 18. X equals 7 pi over 18. Now I need to check and see if these answers are acceptable. This says that I should have a period of what? 2 pi over b. Again, I want, oops, I already highlighted, so I'm going to circle that and circle that. I want to pull my eye that that's where that came from. Okay, well, 2 out of 3, that's 0.67, right? Does 5/18 and do 7/18 fit in there? If I'm unsure, can I just plug 7 divided by 18 in my calculator and see if it's smaller than 2/3? Is it? Check. Use your calculator, use your phone, or long division if you're so inclined. Does it fit? Okay. Then we will accept both answers. All right. Do you feel like you have a grip on this? Is it as bad as you thought it'd be? No, it's worse, right? No, I'm kidding. Hey, but you got to admit it takes your mind off any other problems because it's so weird. All right. What do you think we do with that? Now, I want you to think about, okay, I want to see if you can come up with an answer. Think about what we had to do to solve it with a 3, what we had to do, and now you tell me what you think we're going to do. People at home, you can answer too. What do you think we have to do? Now, the cosine is already by itself. There's no simplifying or factoring. If I said, do this right now, it's a quiz, and you had to try something, what would you try? What? No, I just couldn't hear you. Okay. Of course. Where does cosine equal -1? Right there. So this, it would have normally just been an x, right? Or a theta, and we would have said, well, it equals pi, because that's where cosine is -1. But I don't have just an x there, I have this mess. But that's okay. I'll fix it now. My goal now is to get this little guy by himself. So what am I going to do? I'm going to add pi over 2 to both sides. What's pi plus pi over 2? It is 3 pi over 2, right? Don't ask me why I started to write 33. And now I must get rid of that 2, right? Now let me ask you this question. Can you take 3 pi over 4 and plug it in here to see if it works? Try it. Let's check it in a different color. Check it, right? So cosine of 2 times 3 pi over 4 minus pi over 2 equals, I'll put a question mark, -1. Well, what is 2 times 3 pi over 4? Or can I do this? It's 3 pi over 2. And what's 3 pi over 2 minus pi over 2? 2 pi over 2, which is what? Pi. Is that true? Cha-ching. So I want y'all to notice this is just algebra at this point. When you get an answer out on a problem like this, you can plug it in and check it, right? And think about it. You're saying cosine of some angle equals -1, and I know that cosine of pi equals -1, so I know this thing has to be pi. Don't be afraid to use what you know about algebra to go back in and try things. Don't be afraid to try things. If you miss it, you miss it. We'll fix it. Just as long as we get it by the test time, then we can't just fix it, right? Okay. These are just a couple of reviews from yesterday. A little bit beefed up there. What's wrong with A? Well, I've got sine and I've got cosine, and I can't do that. I have to fix it. If I've got a quadratic, a linear, and a constant, I need the same word. Which one of these is very easy to replace? Go to your list that you've memorized. Which one of those is very easy to replace? These are always easy to replace, right? Because I can replace sine squared with 1 minus cosine squared, right? And remember, when you have an equal sign, either side can replace the other side in math at all, right? Equal means they're the same. So I can replace sine with 1 minus cosine squared x. Do I now have all the same words? I do. So now let's just fix this up. That's 2 minus 2 cosine squared x. I distributed the 2. Now, according to the list we made yesterday, we said we should get it equal to 0 and then combine like terms, right? Do we have some like terms we can combine? This guy and this guy are like terms. They're both constants. So what is 2 and negative 3? Now, I don't like the way this looks. I do not like to factor when I have a leading coefficient that's negative. Can I fix that? Yes. How can you change everybody's sign? Multiply both sides by negative 1. Now, obviously, this side isn't going to matter because 0 times anything is 0. The event here changes everyone's sign. And I will tell you, never will I ever factor a trinomial with a negative leading coefficient. That drives me bananas. I can't stand it. Now I'm ready to factor that. If I'm a brand new kid and this is a little iffy for me, I can think about it this way. Right? I can think about it just like that. I can factor it. Eventually, I won't need to do that, but it doesn't matter if I do it all year. So this is what? 2x and x and a 1 and a 1. There's no other way, right? 1 times 1 is 1. 2 times 1 is 2. Now, this is a plus, and if that is a plus, what does it tell me about my signs? They're the same. And this is negative, so what does that tell you about your signs? Both negative. Doesn't it practically factor itself? Right? Is that right? Okay, so now replace. Make a note to yourself right here. Replace x with cosine x. Make a note to yourself about what you just did so tonight you're not like, where did it go? And these are equal to 0. Okay, now what do I do? Set each one equal to 0? Okay, so 2 cosine x minus 1 equals 0. Cosine x minus 1 equals 0. Cosine x equals 1/2. Cosine x equals 1. Now we'll do our locator spell, right? Then we'll get the right angle, and then we'll name everybody with that angle. So cosine is positive here. Cosine is 1/2 at a pi over what? Pi over 3. So now x equals, I need the 2 pi over 3's here. That's pi over 3, 5 pi over 3. Cosine equals 1. Where does that happen? Right here at what? 0. I can't call it 2 pi because my instructions tell me to start at 0, end at, but do not include 2 pi. What do you think? Is that okay? All right. B is exactly the same, just different words. So I want you to try that. Y'all watching the video, you try that. I'm going to pause recording and give you some time, and then I'll join you back to go over it. Okay, y'all, we're back. And let's get everybody on one side. If you finished it, that's great, but follow through because sometimes once you do it as you watch, you clarify details. So first we're going to get it equal to 0 because that's on our list. We have said yesterday we should get it equal to 0, then combine like terms, then factor. Okay, so 2 tangent squared x minus secant x plus 1 equals 0. I see a quadratic a linear, and a constant. So I know I'm going to have a trinomial that I try to factor. But I have different words. Now I can't have different words, different functions. They're really trig functions. Which one is always easy to replace? The squared one, because he's part of my Pythagorean identities. So even if I haven't quite memorized them, I at least know a guy squared is on the list. So I know to go to the list. If I at least know to go to the list, I'm okay. So let me find him. Let me think. Oh, what is that tangent? Oh, yeah, there he is. Look. Tangent is secant squared minus 1. And I want you to remember, you're a beginning student. This is your first experience with these. If you don't have the whole list memorized, that's okay, but you need to recognize who's on the list, right? Like maybe if the principal asked me who was in my class, I couldn't just name you all off and be like, nah. But if I got a list of kids, I could pick you out. I'd be like, yes, she's mine, he's mine, she's mine, right? That makes sense? So that's the level you need to at least get to. If you can memorize them, that's great. But if you at least know they're on your list. Okay, now we'll fix this. 2 secant squared x minus 2 minus secant x plus 1 equals 0. My like terms now would be this fella and this fella. Most of the time, it's just going to be your constants that are like. You're not going to get, you could get 2 squares, but not likely. -2, +1 is -1, right? Now I'm going to make sure I know what kind of factoring I'm up against. It's a quadratic, a linear, and a constant. That means I'm going to try to get 2 sets of parentheses. I'm going to unfoil. If I had 2 squares, might be a difference of squares or some of my other patterns. But this is quadratic because it's squared, linear because it's just a 1, and constant because it's just a number. What's the only way to get a 2? 2 and x. What's the only way to get a 1? 1 and 1. This is negative, so I know my signs are opposite. I have 2 different signs. Now this is negative, so I want the bigger one to be negative, because when they add, I need negative. This is 2x. This is 1x. Which one needs to be negative? The 2. So that would be this guy. If you need help factoring, please see me. I promise I can make factoring easy, and that opens up. There's a whole world of math out there that all of a sudden becomes easy when you're good at factoring. There's a whole world that will never be easy if you can't factor. Okay, so what am I going to say? 2 secant x plus 1 equals 0. Secant x minus 1 equals 0. Now I got to get that secant by himself. Secant x equals -1/2. Secant x equals 1, right? The problem is I don't know secant. My teacher said I didn't have to learn it, so I have to flip it. What is secant flipped over? Cosine. Therefore, I must flip that side. 1 flipped is just 1. Where does cosine equal -2? Never. Now this, I think, is a tricky problem. It makes you think you shouldn't have flipped that side because you know where cosine's a half. Don't do that. Follow the rules. It's okay if you get a never. It's all right. Where does cosine equal 1? Right there. And that's at 0. We don't want to call it 2 pi because 2 pi is too big. Uh-huh.
I did it the other way, where like I substituted the secant for another tangent, and I got this one.
No, because that could be luck, but secant minus 1 is not tangent. Let's look at our list. That's a great question. Secant squared x minus 1 is tangent squared. You cannot just take the squares off and say secant minus 1 is tangent, because these are the Pythagorean identities. I'm very glad you brought that up. These are the Pythagorean identities, and they come from the Pythagorean theorem. So for these formulas here, you cannot remove the squares. Okay, now for these up here, these are just reciprocals. So we can say cosine squared is 1 over secant squared. We could say cosine cubed is 1 over secant cubed. It's okay to switch them out here because these are just reciprocals. You're just flipping somebody over. But these right here are Pythagorean identities. So for any of these, you must not just take a square off, okay? All right, excellent question. I am so glad you said that. All right, that's it for today. Your homework is in Canvas. Right now it says Delta Math. I'm going to go into Delta Math with you to look at those. And if they turn out to be weird ones and they're calculator problems, I'm going to upload a class kick. I want you doing your brain. Okay. All right. So adios. If you're watching this video, I hope you have the best day so far this week. Adios.